Welcome. It's great to have you all here with us. You know, scientists are amazing people, but what you may not have realized is that a lot of scientists are also great athletes. Maybe you never thought of that. You know, for example, did you know that Buzz Aldrin? He was a great engineer, and he was the second man on the moon. But you may not have known that he was also a star quarterback for his high school football team. So it just kind of goes to show that sharp minds and strong bodies go hand in hand sometimes. And, my son heard about this, and so he decided he's going to form a professional hide-and-go-seek team. But he told me that the good players are really hard to find. So that's what he told me. Well, a little bit of science news today. Researchers at Rutgers University have made an interesting discovery. They used a radio telescope and computer imaging to identify what they believe is an invisible core or substance that's affecting an Einstein cross. Well, what's an Einstein cross? I didn't know, but it's a phenomenon that happens when you have a star that's far away. If you can imagine a star far away, and then there's a galaxy in between you and that star, and it bends the light, and they call it an Einstein cross because Einstein's theory about relativity and the things he helped us learn about gravity help us to understand that the light bends, and so the effect is you see, instead of one star, you see four different stars, what looks like four different stars, but it's really just the light bending. Well, this particular phenomena had a fifth dot, which was supposed to be impossible, but they believe that they've been able to identify dark matter that came into play to be able to create that fifth dot. So something for some of you that are really into that to study. A lot of really amazing things out there in this incredible universe. Well, it's time to get it over to Dr. Joshua for How to Study with Acellus Gold.
Today, I have the honor of sharing an announcement from the National Society of High School Scholars. NSHSS is the world's largest honor society for high school scholars with 2 million members, lifetime members. And the organization was co-founded in 2002 by James Lewis and Klaus Nobel of the family that established the Nobel Prizes. The Klaus Nobel Educator of Distinction Award embraces the Nobel's family's tradition of recognizing world-class minds. NSHSS allows high school members to nominate individuals who have made significant contributions to their academic journey. And it is my great honor today to announce that the National Society of High School Scholars has named Dr. Roger Billings as a Klaus Nobel Educator of Distinction for his dedication to teaching and learning, as well as the difference he is making as a role model, source of inspiration, and a leader in his profession. On behalf of Acellus Academy and our school community, I want to personally recognize and thank President James Lewis for this recognition, but especially I want to recognize and express our gratitude to David Mediu, Acellus Academy alumnus of the class of 2025, for nominating Dr. Roger Billings. Congratulations, Dr. Billings.
That's awesome. Well, it's time to get it over to Dr. John for the Technology Spotlight.
If you could zoom into the future in a time machine, what do you think you would see that the houses and the buildings were made out of? It's kind of an interesting question, isn't it? It used to be that we made almost everything or a lot of things out of wood. And then we used more modern materials like iron and cement. And maybe the future is something like this. Check this out. Wood. Again, a full circle back. It turns out that there's some new research about how we could use wood. This came out of the University of Maryland, and they found that it was possible to treat the wood and engineer the wood and make it much, much stronger. In fact, 10 times stronger than it was before. And here's a little video of demonstration of the strength. First, there's some normal wood. And of course, if you hit it like that, it breaks. And then here's their special super wood. See, the cinder block broke first. And so about 10 times stronger. That's a really big deal because, one of the big advantages of iron and steel and concrete is that we can make very, very sturdy buildings. But what if wood was that strong? In fact, this wood, in some cases, is even stronger than steel, which is pretty amazing. Here's another thing about it, though. One of the big problems with wood, of course, is that it burns when you have a fire. But here's their little picture of it. This super wood is actually fire resistant. It'll char a little bit, but it won't burn like normal wood either. In fact, if you heat up steel to around 1,000 degrees, then it will get soft and it'll bend easy. But superwood won't. It's actually just as strong after it's heated up. So that's an advantage over steel. So by now, hopefully, you're asking the big question, how do they do it? I want to show you a little animation that kind of shows what's going on here. Here's a piece of wood, and first they have to cut it into boards, and then they treat it to remove the lignin from the wood. And then after that, they have to heat and compress it, and it'll get 80% more dense than it was before. And then, of course, they treat it, they resize it, and then they polish it, treat it and everything, and then it's ready to be used for building. So that first step where they're removing the lignin from the wood is actually very similar to the process of making paper. Remember how they have to make the paper pulp? They have to remove all the lignin and they're just left with the cellulose of the wood. And then with paper, they want it all smashed up and then, they bleach it and everything and make the paper. But in this case, they don't want it smashed up. They keep it in that same wood shape, and it's actually kind of soft at this point, and they can form it a little bit before they harden it. And then, once it's like that, they put it into the press. And here's a little video of them running it through the press. See, he's taking these normal boards, well, I guess they have the lignin removed, getting them in there, and then there's the big press that pushes down on them and heats them up. And then here they are coming out. You'll notice they're a little bit thinner. And so when they're heating it and pressing it like that, of course the cellulose fibers are getting closer together. And during this process, there's actually a new hydrogen bond forming, or a whole bunch of them forming, between those fibers. And that's at least part of why it's so much stronger. And there's a company that spun off from the university that's working on this, and they call themselves InventWood. It's a pretty catchy name, isn't it? But they're trying to mass produce this. They just started mass producing it. And there's several other companies that are trying to do a similar kind of thing. But it's kind of a big deal when the wood is stronger than steel, but also lighter, like 80% lighter than steel. And so they estimated that if you were to build a high-rise that was 50 stories tall, that's a really tall building, and you made it out of wood, it would be 90% lighter than if you did it out of steel and concrete. That's a really big difference. And then at the same time, it's much more durable. It can handle the weather, and it's pest resistant and UV resistant and things like that you wouldn't expect. Of course, building with it is a little bit more like building with maybe metal or other composites than with wood because it's a little harder to cut. So they try to ship all the pieces the right size and everything. Here are a few ideas of what they think we could build with this technology. Really fancy. And it's interesting because it's great for outside and for structure, but it's also really great for things like furniture. And they think that since you can use any kind of wood as the starting wood, you could use really affordable wood, like pine or something, and run it through this treatment, and then you could use it for furniture a lot like you would use the really expensive hardwoods. And so it could be a more affordable way to have really nice furniture as well, not just for building buildings. So you can see how maybe in the future it's going to be full circle and we'll be making things out of wood more. And the best part is it literally grows on trees. Yeah. That's all the tech we have the time for.
Well, now it's time for Breakthrough Moments in Science with Tobias.
Well, we're going to talk about the time when NASA went into the unknown. Or I should probably say into the unknown, right? That was a Frozen reference for the children. And for some of you adults, I'm afraid. Great. But no, when NASA went into the unknown, because like in the 1960s, and we were taking Americans to the sun, to the moon, not to the sun, not yet. Okay, be patient. We were taking Americans to the moon, and it was just such an exciting time. Well, one of the dreams of astronomers was, how could we send a spaceship past the moon to our planetary neighbors? Like, if we sent not somebody, but something all the way out there that could send us, like, pictures, think of how much we would discover. Because at the time, we just, better telescopes, we need better telescopes. This is before Hubble. This is way before James Webb. And we were trying to look at Jupiter and look at Saturn and Neptune and our neighbors, and we wanted to research that more. Well, in the 1960s, some engineers at JPL, Jet Propulsion Laboratory, noticed something that was coming up. And it was a planetary alignment. Now, they call planetary alignments when the planets in our solar system, they're all going around the sun at their different orbit speeds. Well, every 176 years, there's a certain alignment that they do where they get nearer each other. And they kind of congregate in one spot together. It's just the right timing. Now, they're still way far apart, but much less than sometimes. And so these engineers thought this could be the moment where we can go to these planets and explore these different planets. Now, they're not as close as they are in this picture, okay? This is an artist rendering. But they suggested a plan to NASA of this could be the window. What if we sent, their first suggestion was we could send a spaceship to every planet right at this time. And they were like, okay, that's way too much money, so we'll never do that. So we could send one spaceship to multiple planets. And they finally got approval to make 2 probe spaceships. They were going to send out to these planets, and one would hit some planets, one would hit the other. And then what would happen? Well, we just let them keep going off into space. And they got approval to do this. They had Voyager 1 and Voyager 2. Now, the biggest part of these probes was going to be the radio dish to communicate back and forth. It's about 12 feet in diameter. Here's a picture of an engineer. He's working on it. See that big dish? And here's that big dish on the top of one of these probes that's going to get sent out. Now, we're going to focus on Voyager 1. But both of these, they were basically, once they finished their mission, they're not going to come back. So they were going to let these just keep going and hopefully maybe even go somewhere no man-made object has ever been. So they started thinking, wow, so we're going to send something into the unknown. And so NASA put together this whole plan of what if it finds aliens? So they put together a team, and the job of this team was to make the communication package for the aliens. So they made this golden record. And it literally is a golden record that they made. It has information like where Earth is in the solar system, how to find us. My wife was like, why would we do that? It's like, we're assuming they're nice aliens, okay? Not like Independence Day. But they put songs on there. Now, the aliens have to figure out how to use a record player. There's not a record player on there, but there's instructions on how to use one. But they put pictures, and they put sounds from Earth, like sounds of nature, sounds of city life. They put brain waves of one of the NASA engineers, who we found out later was in love. Anyway, that's a side story. She fell in love while they were working on this, and then she broke the secret to everybody, and they were like, wait, these brainwaves were when you were falling in love. That's special. So that's out there. And they put it on the side of this Voyager under protection just in case it gets found. Because, again, you have to realize the thought of, okay, this thing is going to leave Earth, and it could go and go and go. Like, I don't know if when you were a kid and you flew a kite and it got so high you almost got a little scared of heights just from how high that kite was, just from thinking about it. Well, thinking about how far this might go, NASA engineers got really excited. Well, finally, in 1977, in September, Voyager 1 was launched. So they launched it up, and off it goes. Its first destination is Jupiter. And here's a picture, not that Voyager 1 took. This is kind of a classic Jupiter photo if you have a pretty nice telescope. Okay, you can look at those stripes you can make out, but notice there's a little dot. And a lot of scientists had theorized, what is that dot? And it seemed to almost be in different places, different times. Well, here's a picture Voyager gave us of Jupiter. And here's one they took of that dot. And that dot can fit multiple Earths inside of it. Has winds of up to 400 miles an hour, and it's constantly going. You know, some of our storms are like, oh, just hold tight, it'll peter out. Not this one. It's been going for years and years and years around the planet. And all of a sudden, we had data we had never had before with details. So after Jupiter, and there's a lot we're not going to cover of what they discovered on Jupiter, things like there's volcanoes, live active volcanoes on one of Jupiter's moons. They saw lightning on Jupiter, which we had never seen before. But now it's time to go to Saturn. And they had this ingenious way to save energy to get to Saturn, and that was start letting Voyager fall to Jupiter. And it starts picking up speed, and then before it gets too close, they changed the trajectory and launched out with more momentum from Jupiter on its way to Saturn. So up we come to Saturn, and about 1 year later, they got to Saturn. Here's another telescope picture. Here's a picture that Voyager 1 took. They were able to see those rings like we've never seen before and actually discover some of what they're made of. They discovered 5 new moons around Saturn. This is a rendering where they took real images and put them together, so this isn't one picture. But they saw things we had never seen before on Saturn, because it's one thing to have a really good telescope, but if you can get up close, what could you see? And it was just so exciting. Well, now, this was the last assignment for Voyager 1. So they were going to let it go. And so you have the planets kind of going on in their disk-shaped orbits. Well, they decided to have Voyager go up and leave everybody, leave the solar system. So out it went, and it had one more assignment. They had it turn around, look back at the solar system, and find Earth and take a picture of Earth. This is like the most faraway wide lens selfie ever. But this is the Pale Blue Dot image. And this is taken 3.7 billion miles away from Earth. And that little dot is where we all are. And it just blew away engineers to be able to see that kind of, now the kind of the shaft of light you see is reflection, lens flare on the lens. But now its mission is just to go out. So it's been traveling and traveling at about 35,000 miles an hour away from the solar system. And in 2012, it reached what we call the heliopause. And that's where the sun's waves start to fade out and slow down. And it crossed over. They weren't sure if it'd make it through because it's warmer at the tips because they kind of condense. And it made it through the heat. And it got out into what is called interstellar. So now we're out of the solar system in interstellar. And it's going, and we can still communicate with it. And the power to communicate with it is about as much power as a refrigerator light bulb. And it takes about 22 hours for that signal to come back. And next year, Voyager 1 will reach the distance of 1 light day. So if you shoot light from here, a laser, where at the direction Voyager 1 is, it will take 1 day for the light to go from here all the way to where Voyager 1 will be next year. That's pretty incredible. So it's the furthest man-made object that we have ever launched, and it's still going, and we're still talking to it to this day, which is pretty incredible. So math, engineering, science can take you, as they say, to infinity and beyond. Thank you.
Well, it's time for me to introduce the creator of Acellus, Dr. Roger Billings. You know, Dr. Billings, many times throughout his career, has been at a point where he saw things ahead of their time, and people had a hard time believing they could be true. You know, when he said, you can run cars on hydrogen, people didn't think that was possible. When he said that you could create a network that would connect all the computers in the world, people thought that was crazy. But over and over, we've seen a lot of them happen. And this is a quote from Necdet Viziroglu, who was the president of the International Association of Hydrogen Energy. He said, Billings was often in a position that he did it first, but no one believed that he really did it. And then when it became a standard, no one remembered who did it first. Well, we're seeing that over and over again, and we're excited to see what's coming next. Please welcome Dr. Roger Billings.
Well, hello, everybody.
Congratulations.
How are you doing today?
I'm doing well.
I was talking to them,
They didn't answer.
always trying to steal the spotlight. It's good to have you all with us today. And this has been a fun Science Live so far, hasn't it? So Johnny thinks you can grow it on trees, huh?
He thinks you can.
Yeah, that's good. You know, that idea of wood, though, still wood that's as strong as steel. And the secret is you put it in a big masher and you put pressure on it and you mash it so hard that the atoms get closer together and hydrogen bonds form.
I thought you liked that.
Hydrogen bonds are so great.
They
And
are.
then it becomes, for the weight of the wood, it's stronger than steel.
It's amazing.
And I just have to tell you, John, Dr. John, that I'm planning to use this new compressed wood. It's fireproof. It's very, very strong. I'm planning to use it in these new homes of the future that we're working on for the part that carries the weight in the structures, which I think is very neat.
Are you going to have curves to them? He said you can kind of bend them.
I'm going to have curves to them?
Yeah.
No.
Oh, darn.
Should I?
Yeah.
Yeah. Okay. Well, we'll work that out off camera.
We like
But
curves.
moving forward, we've got a lot of really interesting things to talk about today. And I'm getting a lot of wonderful questions. One very special Acellus parent reached out last week and said, boy, this gold security sounds really neat. And he actually said, is it possible to invest in that new company? And so I was so touched, I called him up, and we had a little talk yesterday, and it was really neat. I explained to him that my first company, I had zero money. No money. I really thought Bill Lear was going to just load my car up with money when I left.
Well, he kind of gave you that impression, didn't he?
No,
I thought he said he'll make you $1 million. You'd be.
he didn't
What'd
say
he
he would
say?
make me. He said, you'll be a millionaire
You'll be a millionaire.
in 3 years. But he didn't, I thought that meant he's going to give it to me. It didn't.
Yeah.
It meant he gave me the ability to do it myself. And which would you rather have, a fish or know how to fish? You know, you've heard the story. But I've had some people asking, so why are you doing this?
A lot of people want to know.
Every single week, you spend Wednesday night doing Science Live. And why?
Yeah, so why?
Yeah, because I could be fishing.
You could. Yeah, you could.
Love to fish. And it's kind of important, I think, today for me to explain to you why I'm doing it. And some are saying he's probably just doing it for money.
No, a lot of people say that.
And then I would do my day job. I'd go down
Yeah.
the street where we have the for-profit company and I'd work hard on that. But I'm doing it because I believe that you, young people, are the most important asset on this planet. And the future of what happens to Mother Earth is going to depend on you. And I think how fortunate I was for a whole string of what I call life-inspiring giants, science teachers, English teachers, Bill Lear, and others that helped me see the path so that I could be able to do what I wanted to do with my life. And I'm already at the halfway through point, so
Yeah?
yeah.
You have lots of things planned, don't you?
Oh, I do. I have
You do.
dreams. I
He
have
does.
a lot of dreams. I have more projects than I've ever had before.
That's true.
And it's interesting because I now throw out 90% of the projects I would have done before because I'm finally getting smart enough to realize they're not smart. But even so, I only do the real good ones now, but I have more good projects than I ever had. And that's what I love about working at this university, IST. I get to work on so many different projects with students. If I'd do it all myself, I'd have to do just one.
So you got me at life-inspiring giants. I mean, that's a very interesting term. What is it? What makes a life-inspiring giant?
Did anyone hear her say, "I've got her"?
Yeah, my mind got. That is neat.
Wow.
I like
I'm going to say something else really cool.
I like words and I like the meaning behind words.
Be careful what you say. She's
That's right.
listening.
I
That's
am.
all I can say. Today we were talking to the guy that's running the Earth Touch Farm. And that's where we're developing the einkorn wheat and we're developing better fertilizers and healthier food and all that good stuff. And so we were sitting there talking about cattle. No? Why are you blushing?
Go ahead.
You go ahead and tell the story. Tell them what you said, or I will tell.
You will tell them.
No, go ahead.
Well, if you have me talk, I'm going to be noticing you didn't answer the question. Life-inspiring giants.
Okay, so I guess I'm going to have to tell the story myself. So here it is. We're talking about these special Black Angus cows we've been raising as an experimental project. How do you make cow meat more healthy? And there are studies that say that if the cows listen to music, they're happier and they're healthier. So you should actually play music to them because then the meat turns out better. And so I just put two and two together. She was the one, by the way, that
I'm
told
the
us
one who
that. We're
started
sitting there
this.
talking. She said, if you play music
I said,
for
if you
them,
have
they'll be
happy
healthier.
cows.
You have happy cows and they'll be better. And I started.
They'll taste better.
I put one and I put two together and I told John, we should play tapes of social emotional courses to these cows. Can you imagine how good that meat would be?
Be very tender.
Tender,
meat.
yeah. Okay, but we need to move forward. Now, I want to just talk real serious for a minute, though. And
Okay.
forgive me if I'm passionate and maybe even a little emotional about what I'm going to talk about next. I believe in the value of people.
You do.
I think people are the treasure that matters. You are the treasure that matters. And I want to show you a photograph. And this particular photograph is of a gentleman that's not having his very best day. It's appalling to me that we have so many people in this world, especially it's appalling to me, in this wonderful country that are homeless. And there are a lot of reasons why people are homeless. Sometimes, quite often in fact, I think it's because they're ill. But if they're ill, we ought to do a better job of taking care of them.
Yeah.
But there's others that are in this condition because they made some poor decisions. I wonder what is the first poor decision that a person would make that would make them end up without a home on the street. And it could be even a decision about getting into drugs. It could be a decision about dropping out of school. It could be a lot of things, but those decisions start to add up, and then they have consequence. Now, the gentleman in this picture, I don't know, but my heart goes out to him. And what if there is someone in our audience today that is destined to this conclusion, that this is the path you're on in your life, and if we could fast forward a few decades, you would see yourself right there. My goal is to make sure that we turn that path until you're somewhere like this. This could be the same guy, and he's climbing up into his jet to fly off to help someone somewhere. And it's because he made the right decisions. The right decisions aren't always the easiest. Quite often they're the hardest. For example, studying. We have a lot of students in Acellus Academy that are starting to study in the honors mode. That's just like asking for trouble.
Yeah? Why?
Honors, it's harder.
Oh, I see.
It's harder.
It is a lot harder.
And you could just get done and get on to your
Yeah.
activities. It's harder, but they do it because they realize it's building up the gray matter between their ears. And someday, that's going to help them get their jet, get their opportunity. Now, a jet isn't really the end goal for most people. In fact, the thing that you want should be your end goal. And the thing that makes you happy should be the thing you want. Too often, we want things so that we can impress somebody. That's silly. Have a goal of what really you're passionate about. I'm passionate about thinking that while I was here running around this earth, sometimes flying around this earth, that I had an impact on somebody else that turned their path up to a better destination. And I really, really, really want you to think about that. I really want you to make those good choices early on that are going to have the wonderful consequences down the road. And studying hard at the age of a student is one of the most important decisions you can make. You can develop good study habits, you can develop your brain, your abilities, you can develop good health. There are a lot of traps in our world, and unfortunately that's why a lot of people, I think, are getting lost. Don't fall into them. We know better. Okay?
Okay.
Now, with that said, I want to jump in to what we're going to do today, because I'd like this to be a day, and I'd like to do this every time if we could, but I'd like this to be one of those days when we get to witness history in the making. I like to do things that are going to make an impact. Now, when Bill Lear got the idea for his Learjet, he ran home and he set up 4 chairs in the kitchen, and he and his wife, she sat in the right seat, that's co-pilot, he sat in the pilot seat, and he told her we're going to taxi out. He went on his first flight. And later when the plane actually flew, his wife Moya said, "Oh, you must be so thrilled to see your airplane fly for the first time. And he said, my airplane flew the first time that day in the kitchen, because he really dreamed the dream. And I think that's a big deal. So when you take a seed, a small seed, make a little hole and you put it in the ground and cover it over, that is a day that changes history. You can't see any tree. There's no fruit to pick, but you planted the seed that will grow. And the things that I like to do are things that are going to have a really big impact for good. And usually those kinds of things require that you plant the seed today, and it will not grow into a tree for a long time. In fact, many times it will not even grow into a result during my lifetime, but it will be there for those that remain. So what we're going to do today is we're planting a really, really big seed, and I really want to tell you about it. I'm going to start this part of our discussion by showing you a monster machine. This is a tokamak reactor. This is a fusion reactor. This is a machine that harnesses the power of the sun on the earth. And with a fusion reactor, we will be able to have cheap power for everybody for the longest time. And we've been working on fusion reactors for a long time. We call it fusion because, like in our atomic reactors, we call it fission. We take a big molecule like plutonium or uranium, and we break it apart. And when you break that molecule apart, you break that atom apart, you get a tremendous amount of energy. There's a certain amount of that you can do, but one of the problems is every time you break it apart, you get energy, but you also create radioactivity, and you create radioactive waste. And what are we going to do with this? It lasts 100,000 years. Where are we going to keep it? It's dangerous. Fission has been successfully deployed. It's how they make the atomic bomb. But there's another kind of nuclear power that comes by fusion. Instead of breaking a big atom in part, you take some little atoms and join them together. And of course, we're talking hydrogen here. You take hydrogen atoms and put them together and compress them and heat them so they become helium. And when you do that, it gives off a tremendous amount of energy. That's the secret the sun is using to light up our whole world and this whole solar system. So we want to be able to do fusion on Earth, and it's just very, very affordable, cheap power for a long, long time. Well, we've been trying to do fusion for a very, very long time. And we've been doing it with this design called a tokamak. Now the big holes here, and I'm going to try and draw on these with my pen. I hope you can see that little red circle. It's kind of like a kidney bean shape. This is a donut that goes around. Here's the other half here. Half of it is cut away in this picture, but it's shaped like a donut in here. And that donut is where the gases that are going to react are situated. And these are big, giant magnets that squeeze the gas down. The reason we have to squeeze the gas into this donut is because the reaction is so hot that there is no material known to man that won't melt. And so how are we going to hold it? And so we hold it not with material, but with a big magnetic bottle. And so this is the tokamak design to use this kidney bean toroid or donut, and we're going to squeeze it in there. We've been working on this for a long time. When I was in the university, and almost as back when we were writing Dinosaurs, way back there, they told us, boy, this is going to be coming real soon. This is going to be all the free energy. Well, it hasn't come for a long, long time. In this next slide, I'm going to show you the project over in France where we're right now building the next experiment. You see, there's hardly anything to it. Look at these 4 cranes. We, as a planet, have spent $74 billion making a tokamak reactor, or making many of them. We've tried and we've tried and we've tried. South Korea spent, I think, $800 million. Everybody's been trying to make these tokamaks, and no one has been able to make them work. Now they're saying this big giant one they're building over in France, by next year, it's going to be able to give off more energy than they put in to start it up. Not enough to do anything yet, but it's a beginning. And they've been trying to do it all of these years. $74 billion. I have a Russian friend. In fact, he's a scientist. He's passed away now, but he's a very brilliant scientist. If you've ever heard of the supersonic transport, the Concorde, well, he made the Russian version of that plane. They had a supersonic transport too, and he made it. His name was Dr. Nikolai Tupolev, and he's one of the 4 scientists that helped found this IST university. But Dr. Tupolev and I talked about fusion and about the reactor. The tokamak was invented in Russia. This idea of this donut shaped with a cross-section like a kidney bean was invented by a Russian scientist. And they worked on it a long time, and that's where we're putting all of our money, all of our energy, all of our effort. And he looked at me, and I was talking to him about fusion, and he started laughing, and he says, "You know about the tokamak, don't you?" And I said, "Oh, yeah." And he said, we invented the tokamak." I said, "Yeah, you did." And he said, "Yeah, and we gave it to you guys because we knew if you work on that, you'll never have fusion."
Oh my goodness. He really said that?
He said that. He was laughing.
He was laughing at.
But since he said that, we spent another $50 billion, and it still doesn't work. Now, I knew another guy, brilliant physicist named Dr. Robert Bass. Mm-hmm. In fact, he was one of my physics professors, and I really have a lot of respect for him. Well, he figured out what's wrong with the tokamak. And it turns out that the tokamak, when they're getting firing it up, it becomes unstable and it squirts out the plasma gas out of the magnetic bottle. And he came up with an idea that he thought would solve that. He called it the topolatron. The topolatron. And the topolatron was called that because it was topologically stable. And that gets into an advanced field of mathematics. But I looked at the topolatron and I thought it was really interesting. In my opinion, it has a better chance of making fusion than the tokamak. Now, when he shared this with me was clear back in 1976, long time ago. He wrote a big paper on the topolatron. I read it. It was very, very impressive. The whole physics department at the university got excited about it. And they went to the United States government to get funding to do an experiment. They also submitted a research paper to the physics journals for publication, telling about this great new idea. The physics journals would not publish the paper.
Oh my.
And that is a giant problem we have in science today. They would not publish the paper. And why wouldn't they? Well, you see, in science, we have a thing called peer-reviewed papers, peer-reviewed publication. So before they will publish your paper, it has to be sent out to 4 experts in your field, your peers, and they have to look at it and decide whether or not your paper is good science. And unless they give you the thumbs up, the journal won't publish it. Well, it turns out that the money that was being allocated for fusion research was all going to the tokamak. And the people that were doing the tokamak were hiring a lot of experts and spending all of these $74 billion, and they didn't want any other idea to catch on. That's so wrong. That's so wrong. And that happens a lot in science. I really, really believe that we have to stop that. We have to do something about it. There's got to be a better way forward than making who gets to publish so political. We need to have articles written by science peer-reviewed, because there are a lot of people that put out a paper and make big claims, and they turn out to not be accurate. Sometimes they just don't have enough training to really understand that what they've got isn't what they thought. Other times, some people want to succeed so bad that they fudge the data. Science.
Does that mean cheat?
Yeah, fudge the data. That's cheat. Boy, you're just putting it right there, aren't you? Science, in my view, is the search for truth.
Love it.
Science is the search for truth. And if you publish something that you know is not true, you're not a scientist.
Wow.
And I think that's so important. When you do your research, you want to make sure that you don't fudge the data to try and claim a result that doesn't deserve to be there. That stops the progress. It's like when I used to do a puzzle. My family liked to do puzzles. They liked to do them on Thanksgiving afternoon, and they get these great big ones, 1,000 pieces. And I don't see why they had to get pictures that were the ocean and the sky and they were all blue. I like it where every picture, or every piece was a different color, and you look for the colors, but they didn't. So one day, I went in to help, and I'm kind of impulsive. I want to get it done, and I got a piece, and I started figuring out where it went, and they just finished the perimeter. They'd always start with the flat pieces and get the outer shell, and I could not find where my piece went. What am I going to do? I thought if I was smart enough, I could just put it right there in that square, and they would build the puzzle into it. But I didn't know where to put it.
So you, of course, did the right thing.
I didn't know where to put it. So I did the right thing. I put it in my pocket. And I waited.
Not that.
Well, they got all done, and they were looking everywhere for that missing piece, and I came up and said, "Oh, I think I know where that piece is." They didn't think it was funny, but it worked. And I'm not so ashamed of that. It was just timing, the right timing. I went right to the spot. But there was another time that I'm really not proud of. And that's where you get back to science and publishing, fudging data. And that was, I went to do the puzzle, and we're trying to put the pieces together, and there was some there. I found my piece, and I was looking at the shape. Where's that shape? Where's the shape? The shape's turned any different direction. I finally found where it went. And so I put the puzzle, well, they weren't finished. I put the piece in, and it almost went. It was so close to going in. So I forced it.
Oh.
And it went in.
Surprise.
Oh, man. And then I left. When I came back, the puzzle was all done except all the pieces around my piece. And they couldn't get those pieces to go in. They didn't fit. So I pulled my piece out and moved it over where it really went, and then everything came together.
Yeah.
If you give bad data, fudge data, made up data, it just goofs up the whole scientific method. Science is the search for truth. So I believe, and this is going to offend a lot of good people, and so I said, I believe, this is just my opinion, and many people are not going to agree with me, but I believe that if the journals had published other ideas like the tokamak, and I believe there are hundreds and hundreds of others on this most important problem, I believe we would have power plants running on fusion today.
Wow.
But they wouldn't even publish it because they wanted to keep the money under their control coming to them. That's just wrong. So one of my dreams, going clear back to the last century, was to build a journal where we could publish all the research of any scientist that wanted to publish. And you say, but it's got to be peer reviewed. Okay, well, let me tell you the story of how we did it. This is the Science Information System. And tonight I'm very happy to report to you the Science Information System is now live. If you go to science.edu for education, science.edu, you'll see a link there to the Science Information System. And if you click on that link, you'll see that there is a system with 3 parts here: the Journal of Science, the Encyclopedia of Science and Technology, and the Registry of Science. These 3 volumes are what makes up the Journal of Science. Now, to become a contributor to the journal, you need to be a member of the International Academy of Science. I'm the president of the International Academy of Science.
The chairman.
And some of you are going to say, how did they ever choose you to be the president? You say, they didn't.
We voted on it.
No.
What?
I started it.
You did.
Yeah.
He's
it's a
also
good,
the chairman.
Good way to get chosen. So I'm the president of the International Academy of Science, and we have some members, but we just really opened up membership. And this table shows you all the different memberships we have. You can be an affiliate, $10 a year. You can be a member, you can be a senior member, or you can be a lifetime member. I am the first lifetime member, by the way.
No, that's appropriate.
So this is the way you do it. But you only need to be a member of the Academy of Science if you want to publish in the journal. And so it costs you next to nothing to be a member. When you look at the other technical organizations I'm a member in, like IEEE, oh, it's more than that, a lot more. So it's very, very, very affordable. But any member can publish. Now, if some of you aren't a member of the International Academy of Science, you can still enjoy the Journal of Science, because my idea is it's free. A lot of the science journals will publish their abstract. So you do a search on Google, you can find the abstract, but then if you want to read it, you have to go join the journal or buy the article. And I don't want it that way. I want it so that anybody can read the science. And there's a chemistry journal, a physics journal, a biology journal. There's all these different scientific journals. I want the Journal of Science to cover them all. So this will be a broad brush system. I want to gather all of the information. Now, there's a lot of things about scientific journals that I want you to understand, because what we're doing here is groundbreaking. I've never seen anything like what we're trying to do, and I think it's going to change the world. About 55 years ago, 3 other guys and I started a journal, the Journal for the International Association for Hydrogen Energy. That journal now earns $10 million a year selling articles to people over the internet. This journal is published every other month for all those years, and we also do technical conferences. Well, I don't want to sell articles. I want it all available to everybody. So if there's anyone that wants to go read something in the journal, you can. All you have to do is go to science.edu, click on the Science Information System, and there you are. If you want to go search there, you'll find me. I'm there. And along with me are some of the articles that I have written and published on the journal. Now here's where it starts to get interesting. Scientific papers are not credible unless they're peer-reviewed. We want to know what other people think about your work so we know how to rate it. So in the Journal of Science, you can publish your paper. Any member can publish a paper they think's ready. So you publish it, but then all of the other members of the Academy can come in and peer review your paper and say what they think about it. They like it, they see a problem, they don't like it. There is a catch. There's no stabbing in the back blindly. If you want to peer review someone's paper, you've got to do it in your name. You have to take credit for your peer review, which I think is only fair. But now everybody can peer review, not 4 people, everybody. And interestingly, when you publish a paper, sometimes some freshman comes along and finds a mistake you made in the math or something, and it's really, really embarrassing. But your paper is now published in a journal in libraries all over the world, and you're just stuck with it. Not in our journal. In our journal, you never really get through publishing your paper. You publish it, people start reviewing it, and when you see someone's got an idea that you can make the paper better, or if you do some more research and you learn more, you can go in and republish it with the modifications. You can keep upgrading it. So the idea is you publish it and you continue to support and republish it for the rest of your career. Normally, when you publish a paper with a technical journal, you write the paper, you submit it to the journal, and it takes a year for them to get it peer reviewed and then to get it printed. And in research, a year, it's usually obsolete. This way you can publish it today. I'm going to publish a paper, a brand new paper on gold security. This paper I couldn't publish before last week because you can't publish it until the patent work's done. Well, it's done, so I'm now going to publish the paper on the Journal of Science. When I publish it, it's immediately available for anybody to read. And I believe this is going to be the go-to place to publish things. And why are people going to do it here? Because they can publish it right away. They get a lot of peer reviews. If someone finds a flaw, they can fix it. And they can fix it, and they can fix it, and they can fix it. And the papers are just going to get better and better and better, and that's how it ought to be. When you find a paper that was in a journal, you don't know if that writer has already found more information. But here you'll know absolutely the latest information they have.
So you really are a philanthropist.
I don't know what that is. What is a philanthropist?
A person who seeks to promote the welfare of others, especially by the generous donation of money to good causes. He's modest. See that smile?
It sounds like a word that is too long for me to learn.
Okay, so you really are.
I'm a philanthro.
So you really are in it for the welfare of mankind.
Are you just calling me names?
I am. I own that.
Well, I like that. I like
You
to be
really
called
are. You
names.
care about people.
Yeah. But
And
it
truth.
is
And
exciting.
truth.
And I believe this is going to make a difference.
I do
How many
too.
of you remember Aristotle? Some of
That
you
was a
older
minute
people
ago.
maybe knew him. A long time
He was a
ago he lived.
character, yeah.
And he was brilliant, but he figured out that the sun does not go around the earth. Up till him, he figured out that it does.
Yeah.
And it makes sense because it goes around the earth, so it's orbiting. You watch it. It's orbiting. It's going right around, right around. And so the whole world came to believe that. And there's a funny little statement in the Old Testament says, and the world stood still. It had nothing to do with science. And anyway, because of that, the early church leaders, way back in the Dark Ages, decided that anyone that said that the earth wasn't the center of the universe was evil. And
Wow.
they punished them. And people like Leonardo da Vinci and people like Galileo Galilei, they were punished because they were trying to teach people what's really going on. The earth goes around the sun. And you say, well, that was a long time ago. Well, not so long. Have you ever heard of the Hubble Space Telescope? That's new. And it's named after a an astronomer named Hubble, Dr. Hubble,
Yep.
who was studying to see if the universe is expanding or contracting. And he did that, and he found out that it's accelerating in its expansion, which means there must be dark energy because that can't happen. And he was doing all these studies, he was publishing, highly respected. And then he decided if all the universe is moving out, we can backtrack and see where the whole universe started, where the Big Bang occurred. And so he did that, and his data said that it all started right here where the Earth is. Everything is moving away from the Earth. Well, a lot of people have studied that a lot more now, and that's a story I'll save for another day. But he wouldn't publish it because he said that would indicate there was a divine creator, and that's impossible.
It's impossible.
That's impossible.
Oh, okay.
Did you know that scientists don't believe in the divine creator? If you don't know that, look it up. I mean, scientists,
general,
there's just probably an exception, but they don't believe in it. I believe that notion's false. I think there are a lot of scientists that, looking at the data, are convinced there must be a creator. This couldn't exist without a creator. But I think they're afraid to come out publicly and really say it, because you kind of get bashed for that. The Journal of Science is so that everybody can share their thoughts and ideas freely. And you can express a counter opinion. You can even express it in the discussion notes. But every author gets to own their own opinion and speak freely about it. And because of that, I think the Journal of Science is going to be a very, very big thing. Well, we're running a little bit short on time, so I'm going to kind of move on through here. If you go there and look at the Journal of Science, you'll see, and look at my name, you see my papers, and by tomorrow you'll see the brand new paper on the new gold security. There's also an encyclopedia of science as part of this, and this is like Wikipedia. I have spent a lot of time doing the hydrogen articles for Wikipedia, and I go through tediously and put it all together, and then someone comes in anonymously and knocks it all out. It's crazy. And yet there's a real value of information there. So the Encyclopedia of Science and Technology looks, and if you look at this slide, looks just like Wikipedia. It's kind of the same thing, the same footprint, and different people, though, get to be the authors of the article. So we have a person who has a name and a reputation that owns that article, and other people can contribute, but now we have law and order, which I think is a good thing. The last part is the Registry of Science, and this is a registry where anyone in science or interested in science can register and give out the information on the technologies they're interested in and the expertise they have and whether or not they're available to consult. This is a way so that people of common interest working on the same problems can find each other. I predict that this whole science information system is going to be very important and powerful in just 100 years.
100? No, I think it's going to be sooner than that. Sooner than
But
that.
I'm prepared to let it grow slowly. The International Journal, this year after 55 years of hydrogen energy, is the most important journal on the field. I think now we'll start having a subjournal on hydrogen and on the other fields. We're also going to have the conferences that go with this. And this is the first building of our conference center, but we're actually going to be building a much bigger campus of buildings for International Symposia of Science. And we have the ability to carry those live to 25 million viewers around the world. So we can invite all the scientists to attend these big events. I think it's going to be fun.
So I'm thinking about my comment about you being a philanthropist. And this next question, I'm wondering.
Wait a minute. Did she say that she has a comet?
You have a comet. It's
Comet Paget.
JM.
Okay, anyway.
And you don't have to answer this question.
Okay, I won't.
Okay. Would you consider yourself a theistic scientist?
Can you tell me what theistic means?
Theistic means that you believe in a divine creator.
I don't know that I can talk about that on Science Live.
That's why I say you don't have to answer
But
that.
yes, I am. I believe in the divine creator with all my heart.
Okay.
Yeah. Can we move on?
Absolutely.
Okay. According to my watch, we're run out of time. But my dear friend down in the back laboratory
Back lab.
is so excited about SIS and what it's going to mean to mankind. And I just want you to hear his point of view on the subject.
Oh my goodness.
Ladies and gentlemen, boys and girls, welcome to Area 51, where today we're going to learn about SIS. Did you know that, Lady Paget? Because everybody today is excited about SIS. And I'm going to teach you. Look at this. I prepared this special sign so you learn about it. SIS. Super Intelligent Scientist. Yeah. And guess what? Guess who I am? Look right here. It's gonna R51. Super Intelligent Scientist. And I'm just so glad you're here because I have super intelligent scientist in me. Oh, she's so excited about it. I would like to show you what I did to earn my super intelligent scientist status. You know, you don't just get these. If you want to have one of these super scientist games, you have to earn it. And the way you earn it is you make an invention. It's gotta be revolutionary. All right, are you ready for the demonstration of my super scientist invention? Watch this. Super intelligence. Now, I'm going to create a very difficult problem. This is a science problem. And don't get nervous just because you don't know the answer, because I invented this wonderful box. Now watch. 3 plus 4 equals, and we don't know what it equals because we're not a super intelligent scientist. But I do, because I created this super intelligent science box. And so watch now. I'm going to show the box the problem, and now the box is calculating the answer. There it comes. Look at that. It says the answer is 7. 3 plus 4 equals 7. That's amazing. Let's try a harder one. Let's see if this box can do something even harder. How about this? 10 times, 10 times 10. How about 10 times 7? That would be a good one. Let's see. Show it the problem. Show it. Oh, science is so fun. And look at 7, 7, 7, 0. Oh, it says the answer is 70. And guess what? It's right. The box is working perfectly. Now, here comes the next one. What if we put 70 plus 5? What is 70 plus 5? This will be the final test for the box. 70 plus 5. Do you know what it is? Do you know what it is? 7 0. It's 705. 705. That's almost right on. It's just really close. And now I know you're all wondering how I did it. Well, I'm going to tell you the secret behind the magic box. I clipped it together. Yeah, I took this box and I just used my science to clip it together. Now look, and I'll show you. Open it up and look inside. Can you see the clips? That's how I invent science. Oh, you guys, thanks for coming. Lady Page, wave at the kids.
I'm waiting.
Oh, man.
So they want to make sure they know what the website is again.
Okay, so if you want to experience the Science Information
Yes,
System,
they
there's
do.
no charge. Just go to science.edu, edu, science.edu, and when you see the page there are 3 choices. You can look at IST, you can look at SELLAS, or you can look at Science Information System.
That's right.
Once you get into the Science Information System, you might want to go in and go into the Journal of Science, and then you can search for an author by name. And since there's not a lot of names in there yet, it's brand new, you maybe ought to look for Roger Billings.
Good idea.
And you can find the catalytic diet,
Yeah,
and you can find
and
some
more.
other papers.
Yeah.
Because I'm just starting to publish there. Okay?
Okay.
All right, thank you.
Thank you.
See you next time.
Bye.